Hello, everybody. This is Mr. Fasoni. In this video, we're going to be going over chapter 4.2, which is the chapter on the section on, if I can scroll my screen here, the section on adding, subtracting, and multiplying polynomials. So let's get right to it. Our goals are to add and subtract polynomials and multiply polynomials. So let's go to concept one, adding and subtracting polynomials. Let's expand this a little bit. So adding and subtracting polynomials is very similar to the addition and subtraction that we learned in elementary school. The only difference is that instead of keeping track of place values for ones, tens, hundreds, thousands, etc., we're keeping track of numbers and exponents, and the exponents of the variables that are with us in the polynomial there. So just as a little refresher here, when we're talking about addition, if we go back to elementary school, if I've got 478 and I'm adding that to 297, we have to keep track of our place values, right? We got to add the ones and the ones and the tens and the tens and the hundreds and the hundreds. And using our addition algorithm, I add 8 plus 7, I get 15. I put the 5 because that's my ones place there, and I put the 1 over here for my tens place. And then I add that column. 1 plus 7 plus 9 gives me 17. I put the ones, the 1 from the hundreds place in the hundreds column. The 7 is representative of the tens place. And then I add again. 1 plus 4 plus 2 gives me 7, and I get 775. What's really happening here is I'm shorthanding effectively 3 little addition problems. I could rewrite this as 8 plus 7 for my ones digits and get 15. I could do my tens digits as 70 plus 90 and get 160. And then finally my hundreds digits as 400 plus 200 and get 600. And then I'd have to combine all of that together in a 4th addition problem to get 775. So our algorithm that we follow just kind of follows that, or kind of simplifies the addition into a much more compact version. I take up much less space here than I would here, adding things together. Okay, so the big takeaway here is place value is very important. When we're dealing with polynomials, instead of having the place values for numbers that we normally see, like ones, tens, hundreds, and thousands, maybe I have the number 4,703. I've got 4,000s, 700s, 0 tens, and 3 ones. With a polynomial, I might have something that looks like this. I have numbers. We're going to use x as the variable, but it can be any variable. I could have x to the firsts, I could have x to the seconds, and I could have x to the thirds. And my polynomial could be, 5x to the third minus 2x squared plus 17x minus 38. So each of these have a place value very similar to what we see with numbers. The only difference is we can't carry or borrow or do anything between place values. When we're dealing with polynomials, everything happens in one place value at a time, which we'll see when we do the examples here in just a second. So just remember that place value is of the utmost importance in keeping track of what's going on. Let's go ahead and scroll down and look at this equation, or this example rather. So goal 1A is adding polynomials, and we're adding 3x to the third plus 2x squared minus x minus 7. And we're adding that to x to the third minus 10x squared plus 8. So I'm just going to set this up just like I would any addition problem. I'll put this blue polynomial up on top. Since it's addition, the order doesn't really matter because addition is commutative, meaning I can add them in any order. In other words, like if I have 4 plus 3, I get 7. If I add 3 plus 4, I also get 7. So the order doesn't matter with addition. So I put that polynomial up on top, and then I'm going to place the second polynomial below. So I've got x to the third minus 10x squared. Now this is where we have to be careful. Remember, I mentioned place value is important. We've got a plus 8 here. Notice I'm missing having an x to the first power. I've got an x to the third, I've got an x to the second, but I don't have an x to the first. So what I'm going to do is I'm just going to place a placeholder plus 0x in there, and then put my number underneath the numbers column. Now everything's lined up, so when I do my addition, I don't have to worry about things being misaligned, and I can just deal with each place value one at a time. I'm going to go from right to left just because that's the habit we have from normal addition. So I'm going to take -7 and add it to 8, which is going to give me +1. I'm done with the numbers. Now I'm going to go to my x's. I've got -x and plus 0x. So that's just going to stay as -x. I'm going to go to my x squareds. 2x squared minus 10x squared is going to give me -8x squared. And then finally, I'm going to take 3x to the third and x to the third and add those. I'm going to get 4x to the third. So my sum of these two polynomials is 4x to the third minus 8x squared minus x plus 1. So addition is very, very similar to what we've always done since the beginnings of elementary school, except instead of the columns to the right having an influence on the ones to the left through carrying, if I was doing a normal addition problem and I had a value that went above 10, I would carry a 1 over, but there's no carrying with polynomials. Instead of having a column on the right possibly affecting the next column to the left, I'm treating each individual column like it's its own little addition problem. So in a lot of ways, I've got 4 little addition problems I did here to get my final answer. All right, let's go ahead and continue. So the flip side of addition, the inverse operation, is our friend subtraction. Now subtraction we have to be a little bit careful with because subtraction is not commutative, right? If I do 4 minus 3, I get 1. But if I do 3 minus 4, I get -1. So the order does matter. So if I'm looking at this, I'm subtracting 2x to the third plus 6x squared minus x plus 1 from 8x to the third minus 3x squared minus 2x plus 9. Well, really, you got to be careful also with the way it's written. The thing we're subtracting from is my starting value. And then the thing I'm subtracting is my second value here. I'm subtracting 2x to the third plus 6x squared minus x plus 1. So making sure that you put them in the right order is obviously important. And then the other thing to be aware of is that I'm not just subtracting a number, I'm subtracting this entire polynomial here on the bottom. So to add clarity, what I'm going to do is I'm going to put parentheses around this, because this negative sign on the outside is going to affect all 4 of these terms on the inside. So I'm going to apply this negative to everything on the inside of the parentheses. 2x to the third becomes -2x to the third. 6x squared becomes -6x squared. -x becomes +x. See if I can, there we go. And +1 becomes -1. Once I've applied that negative on the outside to all the things on the inside, I can turn the problem into an addition problem. I'm going to clean up these plus signs just to prevent any confusion. And now I can just treat the problem as if it were addition. I'll still start on the right. I've got positive 9 plus negative 1, or in other words, 9 minus 1, get 8. Negative 2x plus x is going to give me negative x. Negative 3x squared minus 6x squared is going to give me 9x squared, negative 9x squared. In other words, negative 3x squared plus negative 6x squared. And then finally, 8x to the third plus negative 2x to the third, or in other words, 8x to the third minus 2x to the third gives me 6x to the third. And now I subtract it. So again, the idea still stays the same as normal subtraction, but again, we are not doing any borrowing from a higher place value to add 10 to a lower place value. We are treating each place value as if they are their own little subtraction problem. And then, of course, I'm flipping all the signs on my second term or my second expression and turning it into an addition problem. So I'm adding negatives or adding positives instead of subtracting positives and negatives, just to keep things clear. Okay, so that's subtraction. Moving on to concept 2, we get a little bit more complicated here. We're dealing with multiplying polynomials. So the key here, it's very similar to multiplication when we just deal with regular numbers. I'm multiplying each term of the first polynomial by each term of the second polynomial. And again, keeping track of the place values is important. So again, I'll do a quick little multiplication example. This should be reminiscent of stuff that you saw in the middle of elementary school, probably 3rd and 4th, maybe 5th grade. So let's do a multiplication of two 3-digit numbers. If I multiply 247 by 183, of course, what I'm doing is I'm multiplying each place value, starting with my ones on my second term, by each place value in the first term. So 3 times 7 gives me 21. Carry the 2. 3 times 4 is 12, plus 2 is 14. Carry the 1. 3 times 2 is 6, plus 1 is 7. But when I finish with the ones place value, and I move to the tens, what I do at this point is I throw a 0 underneath that 1. I do 8 times 7 is 6 for 56, carry the 5. 8 times 4 is 32 plus 5 is 37, carry the 3. And 8 times 2 is 16 plus 3 is 19. So I do the same idea again, but I put a 0 in the ones place. Then I finally do it one more time with the ones place, or the hundreds place, with the 1 there. I put 2 zeros. I'm doing 1 times 7 is 7, 1 times 4 is 4, and 1 times 2 is 2. Finally, once this is all done, I add everything together. And I get 45,201. Well, all that stuff with the zeros, in case you've forgotten, it's because we are actually doing 3 multiplication problems simultaneously in a way. What I'm effectively doing is I'm taking 247 times 3. I'm taking 247 times 80, that's the 8, and 247 times 100. I'm doing 3 separate multiplication problems, and that's where these zeros come from. 3 times 247 gives me 741, like we found before. But once I'm getting to the tens place, I've got this 0 in there because I'm multiplying by 80, not by 8. So if I'm multiplying by 80, my answer is definitely going to have a 0 at the end. And then the 8 is going to multiply by 7, 4, and 2 to give me 6, 7, 9, 1, 19,760. And then lastly, when I get to the hundreds, I've got 100 times 247, not 1 times 247. So what I'm ending up with are multiples of 100, which gives me 24,700. And again, then I have to add all these together once I'm done. And if I added those, I would get 45,201. So once again, I'm saving a bunch of space by doing this stacked method of multiplication. This way makes it more explicit, but it takes up a lot more room. So again, keeping track of our place value is important. And this concept of putting a 0 in for place values that aren't going to happen on the second and third time through multiplication is also important, which we'll see in just a moment. So goal 2.A, multiplying polynomials. So we're multiplying two polynomials together. Multiplying negative x to the third plus 2x plus 4 and x minus 3. Well, I'm going to go ahead and set up my equation just like I would a normal multiplication problem. Got negative x to the third. Notice I've got a third power and I've got a first power, but I don't have a second power. So again, I'm going to put a placeholder in there for x squared. I've got 0x squareds plus 2x and plus 4. I'm multiplying all that by x minus 3. And this is multiplication. I'm using the dot for multiplication because we use x's so much for variables. I don't want to cause any confusion. So let's step through this. I'm going to start off by multiplying my numbers place. It's not the ones place, it's the numbers place, because I can have numbers of any size in this position. So I'm taking negative 3 and I'm multiplying it by positive 4, which gives me negative 12. I take negative 3 and I multiply it by plus 2x. Well, negative times positive 2, negative 3 times positive 2 gives me negative 6. I've got the x there. Going forward, negative 3 times 0x squared. Well, anything times 0 is just going to be 0. And then negative 3 times negative x to the third. Negative times negative is positive, and I get 3x to the third. So I've got 3x to the third plus 0 minus 6x minus 12. That's my first run through of multiplication. Then I have to do it again with my x's place. So the second place value over. So I'm multiplying x times 4, but I'm not going to write 4x here because that wouldn't have my columns lined up. So just like multiplication with just regular numbers, I'm going to throw a 0 in there as a placeholder. And when I do x times 4, I get 4x over here. And I continue along. X times 2x gives me 2x squared. And then finally, I've got two more actually. X times 0x squared is going to give me 0x to the third. And x times negative x to the third is going to give me negative x to the fourth. I didn't really need to write x to the third there. I think that was just habit. It's just a 0. 0 times anything is going to be 0. So finally, after I've done all my multiplication, I'm just going to add this stuff back together. And I'll start on the right again. Negative 12 plus 0 gives me negative 12. Negative 6x plus 4x gives me negative 2x. 0 plus 2x squared gives me 2x squared. 3x to the third plus 0 gives me 3x to the third. And negative x to the fourth is just negative x to the fourth. It's not being added to anything. There's technically a 0 up there, but I didn't put it in because I didn't go that far to the left on the orange row there. So when I'm done multiplying now, I've got my product, which is this 4th degree polynomial, which makes sense. I'm multiplying a 3rd degree polynomial and a 1st degree polynomial. And when you multiply powers, x to the third times x to the first is going to equal x to the fourth. So it makes sense that we have a 4th degree polynomial now. All right, let's go ahead and continue. This is a little bit of a different idea. What happens when we multiply multiple binomials. In other words, I'm multiplying x minus 1 times x plus 4 times x plus 5 times x minus 2. Well, the nice thing about multiplication is that it is like addition. It's commutative. Think about if I did 2 times 3 times 5 times 7, the first 4 prime numbers. I can multiply from left to right, no problem. Get 6 times 5 times 7. I can keep on multiplying, and I get 210. Or I could start on the far right, and I could multiply. And I can keep on multiplying on the right. And 2 times 105 is still 210. So the nice thing about multiplication is I can multiply in any order I want. I could do 3 times 7 times 2 times 5, and that would still work out to 210. So the same thing holds true when we're multiplying binomials. I'm going to erase this here. Just try to finish this in here. I can erase all this. All right. So I've basically got this situation. X minus 1 times x plus 4 times x plus 5 times x minus 2. Well, I can just pick any two I want to multiply together. I'm going to pick the first two, just because I like to go from left to right when I multiply if I can. And I'm just going to treat this like its own multiplication problem. Now, since it is binomials, I could do FOIL, and I'll show that over here on the right as well. But I could do x minus 1 times x plus 4 in the normal multiplication style. 4 times negative 1 is negative 4. 4 times x is 4x. Put a 0 below. X times negative 1 is negative x. X times x is x squared. Add them up. Now I've got x squared plus 3x minus 4. I could have done this in FOIL as well. First times first. Well, let's try that again. First times first is x squared. Outer times outer is positive 4x. Inner times inner is negative x. And last times last is negative 4. And I just have to combine the like terms. I get positive 3x there, and I bring down the other pieces. And sure enough, I've got the same expression. Well, now that I've done that, I've multiplied the first two terms together, and I've gotten x squared plus 3x minus 4. Well, what I can do is I can continue multiplying here. I'm going to rewrite this expression as x squared plus 3x minus 4 times x plus 5 times x minus 2. Well, if I want to multiply again, now I can just take the next two in the problem and multiply them together. I'm going to go into this empty space down here. So x squared plus 3x minus 4 times x plus 5. Just going to get a little bit bigger each time because I'm adding another x. So now this is going to be go from a second degree times a first degree to a third degree now. So positive 5 times negative 4 is negative 20. I'm going to have 15x, and I'm going to have 5x squared. That's my first row. Second row, I make sure to put that 0. Negative 4x, 3x squared, and x to the third. And again, I just add it all together. Negative 20, 11x, 8x squared, and x to the third. So now I can substitute again, and I end up with x to the third plus 8x squared plus 11x minus 20. Try that again. Minus 20 times x minus 2. So then I just continue multiplying one more time. I set it up the same way I did before. This is a little bit of extra writing. If I were just doing this, I wouldn't have rewritten it like that. I would have just move right on to the next problem, but I want to make sure that everybody's clear on what I'm doing. So I've got x to the third plus 8x squared plus 11x minus 20. That's correct, right? Yep. Times x minus 2. So I'm going to go through and multiply everything. Negative 2 times negative 20 is positive 40. Negative 2 times 11x is negative 22x. Negative 2 times negative 8x squared is negative 16x squared. And negative 2 times x to the third is negative 2x to the third. Next row, I do the x times negative 20. Make sure to put that 0 there. I get negative 20x. X times 11x becomes 11x squared. And x times 8x squared gives me 8x to the third. And then finally, x times x to the third gives me x to the fourth power. Again, last time I have to add these now, I'm going to end up with 40, negative 44x. Let's see here, negative 5x squared, and 6x to the third, and finally x to the fourth. So my answer now is x to the fourth plus 6x to the third minus 5x squared minus 44x plus 40. So the big takeaway from this section is that when we add, subtract, or multiply polynomials, none of it is too different than what we did before. We just have to be very mindful of place value, making sure stuff's all lined up nicely. And there's just a lot more little operations. So if we're careless, the chances of making a little mistake and causing problems down the road are increased. You know, when I multiply, a 4-term polynomial times a 2-term polynomial, that's a lot of different multiplications, a lot of different signs. Typically, when we're multiplying numbers, we have either they're both positive, they're both negative, or one is positive and one is negative. On this, I've got multiple signs, right? Positive, 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 and then I've got at the end here 2 negatives, which causes a lot of difference with all the signs down below. I've got a negative, a negative, a negative, another negative. When they add, I get a negative here, a negative there. And then my positives are also kind of just all over the place. So keeping track of those place values and keeping track of the signs are going to be your greatest ally there. All right, I hope this was informative. I'm going to go ahead and post this. The video for 4.3 is going to be coming out right after this as well. That's the division one for polynomials. It's a little bit more involved. So I'll see you in that video. Thanks, guys.